you are able to do that, yeah, the algebra will get messy, but you won't be able to write. If you do a little bit, if you try hard, I'm sure you can figure out your scalars there. Oh God, I know this again. Your scalars here, k and l, so that each of these three vectors here can be written as a linear combination. Can you think of any vector? Can you think of a vector that cannot be written in terms of b and c? I don't think so. I think you can actually, if you're good with your algebra, you can find values for k and l so that any vector in the xy plane can be written in terms of b and c. So there you go. I knew from before that I can generate any vector in plane xy, in the plane xy, using the unit vectors I and j. I already know that. Any vector. You give me a vector, or I give you a vector, and I can write it in terms of I and j. Now, it seems like if I pick these two vectors, b and c, which are random vectors, I pick b and c, and I can still write any vector in plane A, in plane xy, in terms of b and c. Quite an interesting observation. Now, what I basically show you here is that vectors I and j, these two vectors, I and j, span R squared. So that means using just I and j, I can generate, using just I and j, I can generate any other vector in plane xy. But I can move further and I can say using b and c, just b and c, these two random vectors, I can still generate, using parallelograms, linear combination, I can still generate any vector in plane in R squared. Let's move on. How about these two vectors, vector 2, 4 and 4, 8? Can I span with them again R squared? Can I span R squared using these two vectors, 2 and 4? It seems like any two random vectors I'm using, I can generate any vector in plane xy. Let's see. Two random vectors, 2, 4 and 4, 8. First of all, let's draw these vectors. 2 and 4, where is 2 and 4? Is right here. 2 and 4 is right here. And 4 and 8 is right here, I believe. Oh, good. So, let's draw the vectors. I'll do it by hand. 2, 4 is my vector A here. Let's call it B actually. Vector B. And the next one, so this is B of 2 and 4. And the other one is, let's make it blue. And this is vector C of 4 and 8. There you go. These are the vectors. Now, use these two vectors to generate any other vector in plane. In this plane. For example, generate for me this one over here. Negative 2 and 3. Are you able to multiply each of these vectors, B and C, by a certain scalar, and then use your parallelogram rule to get vector negative 2 and 3? Are you able? The answer to this question is no. You cannot do that. You can try as hard as you want. You don't really have. You can't do that. What is the reason? The reason is the two vectors B and C are collinear vectors, which means they are on the same line. They belong to the same line. If they are collinear, nothing I can do to get to my vector negative 2 and 3 The only vectors that I can generate are vectors along the same line. Those are the only vectors I can generate. Definitely not vectors in R squared. So what is the condition about two vectors in B and C? What condition do they need to satisfy in order to span R squared? What they need to do, they need to be non-collinear vectors. Non-collinear vectors. Okay, so vectors that do not belong to the same line. Okay, let's expand our discussion in R cubed now. Let's move in R cubed. Let's go 3D. And let's see if we can have the same kind of discussion in R cubed. Sure we can. Can I talk about linear combinations in R cubed? Sure I can. We already had that conversation when we wrote a random vector. I picked a random vector for you, 2, 3, 4, and I can write it as a linear combination of the unit vectors, 2i plus 3j plus 4k, where my three scalars, I need three scalars, k equals 2, l equals 3, and m equals 4. Beautiful. Now, no concern here, we have already done that. Now, I have another vector here. I have the vector A, 8, 6, 12. Please notice how I wrote this vector. I wrote it as the sum of the vectors 2 to 4 plus 4, 10, 6 plus 2, 4, 2. Let's see, is it correct? Is my math correct? 8 equals 2 plus 4 plus 2a. 16 is 2, 12, 16, 12 is 10, 12. Yes, my math was good. Now, what did I say here? I said that vector A, I'm going to call this vector A, can be written as the linear combination of vectors B, C, and D. This is what I have here. A is nothing else but linear combination of B plus C and D. Now, you're going to say, yes, but you don't have a scalar. Of course I have some scalars. They are k equals 1, l equals 1, and m equals 1. Nothing stops me from picking this. Your task is to think of the graphical meaning of this expression over here. What is the graphical meaning of this expression? Anything else? No, that's it for today. Thank you and see you tomorrow in class.